All right, in this problem here, we've got a square piece of cardboard with a length of 1 meter. So can you believe it? We're using the metric system. All right, so we'll say that the length, should have known. Now you could say the length, the width, whatever you want to say. One of the sides is 1 meter. Considering it to be a square piece of cardboard, both sides are 1, right? Are 1. All 4 sides are 1 meter. Okay. We're going to be cutting out some the corners, and we're going to be cutting squares out of the corners. So that's what this, let's see, we'll do a different color here. Right, so we're going to be cutting out some squares out of here. All right, and then we're going to be measuring the new area. So the new area is all this area in here. This would be the new area. Okay. Minus squares that we cut out. So what we're going to do here is we're going to write an equation, as usual, and we're going to solve for x. It's pretty much that simple. Or solve for W or L or whatever it is. All right, so let's see what it says here. Real quick, I'm going to reread this. A square piece of cardboard with a length of 1 meter has 4 equal squares, or I should say 4 equal squares are to be cut from each corner. The new area should measure a ½ meter squared. What is the length of each square? Okay, what's the length of each square? Okay, so we know that, let's write an equation that represents the area. So the new area is going to be a ½ meter squared. Okay, that's what we do know. The new area will be a ½ meter squared. The area before we cut out the squares in the corner, that total area is 1, right? We have 1 times 1, which is 1 squared. Okay, we're going to subtract off each one of these squares. Subtract the area off of each one of these squares. Well, we don't know what this side is, so we're going to let that side be x. And we know that there's 4 of them, right? And so the area of this square is x times x, which is x squared. But there's 4 of them, right? We have 1, 2, 3, 4. So this number here represents the total area of all the squares that we cut out. That's of each corner. This area, the 1, which is really 1 squared is 1, is the total area of the cardboard before we cut the squares out. So the total area of the cardboard minus the area of the squares gives us a ½ meter squared. So now we have an equation and we want to solve for x. So let's do that. Now, I'm going to rewrite this. Never mind, I'm not going to rewrite it. Okay, so this say over here on the right hand side, if you remember, we had a section on factoring binomials. And this happens to be the sum of 2 squares, or the difference of 2 squares, is what this really is. And we're going to rewrite this. Actually, we're not going to rewrite this. What am I doing? We need to get this in some kind of form here. And that is, we're trying to solve for x. So we need to take this half over here to the other side. In other words, we want to subtract a half from both sides. So we end up with 0 is equal to 1 minus a half minus 4x squared. Okay. So that's going to leave us with 0 is equal to a half minus 4x squared. Minus 4x squared. See that? Okay. Now what we're going to do is solve for x. Now, I got it in this form actually for a reason, and now that I think about it, there's something that we haven't talked about up to this point, and that's square roots. So I should have probably just started with the beginning, solving for x, but that's okay. All right, what I'm going to do here is because this says a minus 4x squared out here in the front, I'm going to take this over to the left-hand side of the equal sign, so it becomes a positive 4x squared. In other words, we're adding 4x squared to both sides. That's all we're doing. Okay. Now I'm going to multiply by a fourth to both sides to get this to be a 1. And that's really going to be 1 over 8. All right, just take the 4 directly diagonally down. 4 times 8. Hopefully you understand this. Now here's something we hadn't talked about, and that's dealing with powers when we're solving for x. So you're going to learn something new here real quick, and we'll actually have an entire section on this. But to solve for x in this problem, you're going to do what's called taking the square root of both sides. We're going to square root both sides. Probably going, what? Don't worry about it. I got a whole section on it. So this becomes x is equal to, when you square root a square, the square goes away. X is equal to the square root of 1 over 8. 1 over 8. Plug that in your calculator, and that's going to be approximately 0.35. Now remember, we're working with meters, okay? We're working with meters, so don't forget to leave off the m there for meters. I ran out of room, so I had to write it below. And actually, I'm going to check that just to make sure, because I haven't seen this problem. I did this a long time ago. Make sure that's correct. 0.35. It comes out to be 0.35, 355, 339, whatever. But we just round 2 decimal places. That's all we did there. Okay. So x is going to be 0.35 meters. 0.35 meters. See that? Okay, so it's important. Take a problem, set up an equation, solve for x. It's just that simple. Okay? Alright, that pretty much ends this. That's 8 minutes has gone by now. And anyway, we got a lot more application problems coming. See you in the next one.